There we go. Parallel circuits have more than one pathway for the electrons. So, some of the things that we notice in a parallel circuit, well, let's see. Let's take, oh, I've got one right here, all ready to go. Here's a parallel circuit. What I want you to notice is I have all of the sidebars connected. All right, so I actually have more than one pathway for the electrons. If I put the battery on, oh, it's blindingly bright. Let's take that off for just a second. Poor document camera's having a hard time now. But you saw how bright those were. What if I put a third light bulb on there? If this were a series circuit, what would happen? It would get dimmer. Let's connect that. Let's see if it gets any dimmer. You notice it any dimmer? Not really. Maybe slightly, but gosh, it's still pretty blinding. I think the camera adjusted a little bit better that time. But it's still going to be pretty bright. If I put a fourth one on there, if I put a fifth one on there, what will happen? Let's just attach this, come on. There we go. What if I unscrew the light bulb? Yeah, the others are still there. What about maybe it's just I need the middle light bulb. No. What about the top light bulb? I mean, I have the battery connected right there. Oh man. Nope. This is what makes the expensive Christmas lights different from the cheapy Christmas lights. Has to do with this. I can lose a bulb, but I don't lose the whole thing. Or maybe how your Christmas tree, my Christmas tree has lights already on it. That's why I love it. So I don't have to string. That was always the worst. You'd be so excited to do the Christmas tree, and then my dad would spend 3 hours putting the Christmas lights on, and you'd be so bored by then that you couldn't even bother decorating the darn thing. You'd have to go back. Yeah. Oh well. Alrighty. So the parallel circuits, we have more than one pathway. You don't lose all your bulbs. So when one bulb goes out, you don't lose everything. Okay, so advantages here. Well, I'm just going to draw an arrow. That's the main advantage of a parallel circuit. You know, you blow dry your hair, and you might knock out the bathroom light, but that doesn't mean that the refrigerator just disconnected. Yes?
It's kind of like for ceiling fans too.
In what way?
Like,
oh, you mean with the blades?
No, like the lights.
When you turn off the lights, the blades can still go?
No, like if there's 3 lights and one light goes out, the electricity light.
I think, yeah, but I believe that's a little bit different only because usually you can click it and then they go out in sequence. Am I thinking of the same thing?
If one bulb burns out.
Oh, okay. If it burns out, sure. But I think what I'm thinking about are lights where you turn it and one light goes, or all 3 are on, but then 2, then 1. Do you know what I'm talking about?
Yeah, I kind.
I thought that's what you meant.
No.
No? Okay. Yes, you're right. No, I don't know what I'm talking about. There we go. Everybody's happy. Okay. So we have more than one. This is an advantage that we don't lose it all at the same time. However, a definite disadvantage. There's definitely more risk of fire here. You can get, those plugs you put on a plug so that you can plug 3 or 4 more things in at the same time. These are on a parallel circuit. So what's going to happen here, the current is going to increase on a parallel circuit, which we'll show with the math in a little while. All right? The more items you put on a parallel circuit, the overall resistance of the system goes down and the current goes up. More current means more heat, and you can have a risk of fire. That's why you have circuit breakers in your houses, circuit boxes that actually will switch the circuit off if it gets too hot. That's a safety measure. Second disadvantage, if you're working with a battery, this will drain your battery faster. How come? Because there's more than one pathway and there's equal push on those pathways. If you have a 9-volt battery and you have 3 pathways, each pathway gets 9 volts. you're going to use that energy up from your battery a lot faster than on a series circuit. Granted, you'll be able to see everything, so you have to weigh the benefits versus the disadvantages. Really up to you what you want to use. All right, but they definitely have some benefits over the parallel circuit or the series circuits. In terms of the math, like I said before, our relationships with current they're different. The current splits among the resistors. That's different. It's just the opposite. The volts remains the same. And the way to find the total resistance in a parallel circuit is also different. The more items you add onto a parallel circuit, the lower the overall resistance. There's an inverse relationship. You don't just add them up anymore. You're going to add up 1 over R1, 1 over R2, and that's going to be equal to 1 over the total. So you're going to be using the inverse button on your calculator quite a bit, unless you're really great with fractions. And you might be, but when we're dealing with 2.2 for a resistor, I doubt you're going to want to find a common denominator. Okay, but the steps that we want to take are still the same. When you're solving a problem like this, to figure out a parallel circuit, first thing you want to find is the total resistance. The next thing you're going to want to do is, if you don't already know it, find your volts. Hopefully you do. And then the third thing you're going to want to do is find out your individual currents. Same idea. We're going to find these things. And again, we're using Ohm's law over and over and over again. But you have to keep in mind what happens in terms of the difference between your circuits. So I'll walk you through one, and then we'll see if we have time to finish with another one. All right, so I'm going to look at your last, or not your last one, not the one with the light bulbs, the one with just the resistors, so the second to last one. Is anybody still writing? All right, let's go here then. All right, let's make this a 10 ohm resistor. Let's make them both 10 ohm resistors so that you can see that the resistance isn't 20. It actually drops quite a bit. And I don't know, let's make this again a 9-volt battery. That'll work out. Okay, first step, find total resistance. We only have 2 resistors here, so it's not going to take quite as much. All right, we don't have to keep going here. 1 over RT equals 1 over 10 ohms plus 1 over 10 ohms. The nice thing that making them the same is that I don't need to do a lot of fancy math. I can add them up because they do have a common denominator. So 2 over 10 ohms is going to be 1 over RT. What that means to me is that RT is going to be equal to 10 over 2, which is 5 ohms. I flipped it over. I flipped them both over and did the math. My overall resistance of the entire circuit is less than the individual resistors in it. That right there tells me that if I know V equals IR, and I do, well, if this R goes down, that means current goes up. That's why it can be dangerous. The more parts you have on a parallel circuit, you're going to increase that current because your overall resistance goes down and your total volts is the same. So your current goes up, which means more heat, which can mean a fire. All right, so our overall resistance is 5 ohms. We know that we have a 9-volt 9-volt battery, excuse me. Since when I get to this juncture, the push can go both ways. And it's a 9-volt battery. I have 9 volts of energy going across each branch of my circuit. The battery pushes equally through both. Pushes equally hard. Again, that'll drain my battery a lot faster, but it changes my math. So before, when we had our series circuits, we were taking our current and making it the same on both branches. What we're doing now is we're taking our voltage and making it the same on both branches. And I'm going to find the current in each branch, and I can also find the total current. Let's find the total current first. Total current using V equals IR. What should I be dividing? Jessica, what should I divide?
V divided by R.
V divided by R. Now I want my total voltage, which is 9 volts, and my total resistance, because I'm finding my total current. IT equals 9 volts divided by 5 ohms. 1.8. 1.8 amps. That's a pretty high current. That could really do some damage. A lot of heat there. Now, if I go and I find the individual branches of my individual resistors, it should add up to 1.8. Considering they're the same, I could just split this in half in my head. But let's do the Ohm's law math. All right. The current for number 1 is going to be 9 volts divided by 10 ohms, because that resistor, each individual resistor, is 10 ohms. So 0.9. And the same works for I2. Because they're the individual resistors there. So it's a little bit different. How are we doing? So far, so good. We've got about 1 minute left, or like one problem left. Let's take this last one. I'm about out of room, so I'm going to put it on another one. Let's see if I can just have you figure out quickly if I give you different resistors. Let's make that first resistor 10 ohms. Let's make the second resistor 15 ohms. Let's make the third resistor 20 ohms. First, find for me the resistance of the circuit. Maddie, what am I going to do? 1 over what plus 1 over what?
1 over 10 plus 1 over 15 plus 1 over 20.
Right. 1 over 10 ohms plus 1 over 15 ohms plus 1 over 20 ohms. So this is where your calculators definitely come in handy. We want to add those up. 1 divided by 15 plus 1 divided by 20. Take an inverse of that. So this works out to 0.216. RT, 4.61 ohms. So the total resistance for my circuit is 4.61 ohms. It's a lot less than any individual resistor. If this is a 12-volt battery, I'll give you that as a 12-volt battery. To find my total current in the battery, or in the system, what would I do using V equals IR? Colin, what should I do? Excuse me? I want to find the total current in the whole circuit.
Take total volts divided by the resistance.
Exactly. Total volts divided by total resistance. So 12 volts divided by 4.61 ohms. It's going to be a really high current. Ooh, 2.6. Now let me ask you, is this going to split evenly? Should I just divide 2.6 by 3? No. I'd have to figure it out individually using V equals IR on each branch. All right, thanks very much, guys. And